What up, homies? So this is so this is it's business calculus, math 1325. Sorry, that intro kind of yeah, threw me off. Anyways, differentials. We're going to learn about differentials here. So differentials is kind of like derivative, and again, we had saw differential properties and all those, or differentiation properties. I said derivatives. This is derivatives. We got to talk about what they're going to be talking about, though. First off, let's start with some notation. This, if I could draw it correctly, that is delta x. That is a delta x. Now that's a capital delta, and d. It's like saying a capital D in Latin, but this is a Greek letter, delta. And what it means is change. So delta, capital D, delta means change. So this is change in x. So that's delta x. And let's similarly see that we got delta y. That's going to be a change in y. Now what's interesting is they're using D, right? This is just a Greek D. Well, then what if I use the Latin D instead, and not the capital version, but the lowercase? And oh my gosh, I've seen that before. So D, I saw that last time, and it stands for derivative. And that's exactly right. It's all interrelated. So I'm going to just say that when you see a delta, it's kind of like saying D for derivative. So if you see delta x, it's kind of like saying dx. And one of the problems coming up is going to say delta y divided by delta x. And so they're basically saying dy dx, which we already know is y prime. That's my just regular old derivative. Now, that is not the entirety of differentials. I can't just say, there you go, because there actually is a lot more going on. But we'll see those through the problems. But I need to have it in your mind that when you see delta something, it kind of means derivative, it means change, it means the same thing that we've been doing, okay? So it's not a drastic move here. I do want to give you official formulas, okay? So this is just a concept here. I would say official formulas, which we will be using, is this guy right here. It's a very simple one. So delta x is x2 minus x1. And I know that seems almost too easy, but I'm saying what's the change? What's the difference? Differential difference, derivative. Yeah. See, it's all coming together, right? And then so delta y would be y2 minus y1. And where have I seen these together? I don't know. Let me just remind myself. Delta y over delta x. If you put those formulas together, it's the slope formula. Slope? Gosh, haven't I seen slope before? Oh, yeah. That's my derivative. That's my y prime. They're all the same thing. So what we will be doing is we're going to be finding slope, and sometimes we'll find a derivative, and there you go. Kind of depends on the application. Sometimes they'll give you some points. We got to follow it. There you go. There's your formulas of the day. Let's go and just do some problems. So let's do this. So we got y is equal to 2x to the fourth. And they say x1 is equal to 2, and then they say x2 is equal to 5, and they want to know what is delta x and what is delta y, and then they want to know what is delta y over delta x. Now, I think, no, that is exactly it. Okay, yeah. Some of these problems will just ask for this one, and we have to go and find those anyways. So this is x2 minus x1. So that's 5 minus 2 is 3. Waboom. I mean, it is the first problem of the section, of course. I feel so accomplished. So here we're going to plug in the 5. So 2 times 5 to the fourth, and then minus 2 times 2 to the fourth. And I got this one wrong, and I was staring at it forever. Why am I getting this wrong? It was because I had put a 2 right here instead of a 4. And that's just, I don't know if I'd call it dyslexia or something, but it would be a mistake. That it's just too many 2s, man. It's too many 2s. See, I just put a 2 up there, and I was like, why is this wrong? It's a 4. It's a 4. It's okay. All right. Well, I have to laugh at it, okay? So I've got these two guys here, and they say divide them. So I got the 1218 over the 3. So I divide those, and I'll just give you the answers 406. So there you go. There's my 3 answers that they're looking for. What is this guy? It's your slope. It's your slope. Oh, wow. Thanks, Chad. You're welcome. My name's Chad, by the way. So I got 35 plus 14x minus 2x to the 5th. And they say, find dy. Okay, pause. So this is when we really do the real differentials and implicit differentiation, all this other stuff. There's a lot going on, and I love it. And I love it more so as a concept for other mainline calculus classes. I think that what we're doing here is really neat, but you're only getting a small bit of this. Like, I don't know how far you're going to apply it in this particular manner, but I do want to show you as a professional mathematician here, I do want to show you what we need to do here. And so we're saying find the derivative. And I kind of want to say like y prime. It's not quite that, but it's basically that. So let's just find y prime. I'll get to the point here in a second, okay? So the 35 goes to 0, and I got a 14, and the 5 comes down with the 2, makes it 10, minus 1 from the power, and there you go. That's the answer. Yay! No, it's not. It's not the answer. But it's really close. It's really close, okay? Let me show you the answer, and then I'll give you the whole like spiel here. It's actually 14 minus 10x to the 4th, all of this in parentheses, times dx. That's what my math lab wants, okay? And they did not do anything wrong here. They're just wanting it very picky. So I found y prime, which we have seen before is actually equal to dy dx. And so dy dx is equal to 14 minus 10x to the 4th, okay? Well, they're wanting only dy. And did you actually think that this wasn't division? Because it is, and I can now multiply that to the other side. Thank you, Leibniz. And so, that was Leibniz method. I don't know where I said that. Anyways, versus Newtonian. Okay, so just get all wrapped up in it. There you go. We did it. So it is the derivative. Just slap a dx on there, and you're good to go. So if they don't have a dx, include a dx. It's good advice, I think. Let's keep going. Again, I'm always torn between wanting to do the exact concept versus doing what you just need to get done. You know, it's a hard place between, okay? So we have a y, they say find dy. So you know you're going to have a blah, blah, blah dx at the end. That's fine. So we're just finding a derivative here. And if you look at this, oh no, it's quotient rule. And no, it's actually not. If we split it up just like we did the last time we had this happen, it makes it much easier. They are making this easy on purpose for us, because later it will not be that way. So be happy that we're doing it now. This is actually a -1 power, okay? So then I'm now going to do my derivative of this guy. And so 8, and then we have the -1 comes down, and -1 from the power. If you want to make it fancy, I guess this guy. So there's my derivative. But I shouldn't be boxing it in. Rather, that was dy dx. And I'm wanting to find dy by itself. So I multiply the dx to the other side. So dy is equal to whatever I found, my actual derivative, dx. There you go. That dx is going to come in handy later. I think actually in the next problem. Yes, on the next problem. So I'm going to show you why we're doing this on the next problem. And then we're going to get into some interesting stuff here. So here we go. Next one. 9, 6, 27. So I've got y is equal to x cubed minus 9x plus the 4. X is equal to 5. And then I got dx is equal to delta x is equal to 0.1. Okay. So, and what they're wanting here is they say find dy and then find delta y. These are a little different, okay? So this is, again, similar to saying find y prime, right? It's I'm wanting to find my derivative, essentially. But now I have an actual formula. I have an actual formula for this one. This is that y2 minus y1 business, okay? What I want to do is I want to do the easiest thing first, and that's actually the part B. Without going way overboard here, I need to find what my x1 and x2 are and plug them in and just right here, and then we're done. So we already have this guy, and then we have this thingy. Again, remember that this is supposed to be change. So let's just call the first one the 5. So we're starting at the 5, which is awesome. And then I'm changing it by this much. I'm saying, and that's a positive, okay? This is positive. So I'm going to say that my x2 is going to be 5.1. I'm changing, I'm adding that much to it. So here's my 2x points. So if they had said, no, never mind. They already gave it to us. Just forget what I was going to say there. Okay, so because I'm going to take these and plug them in to find my y values, like y2 is whenever I plug in x2. And so I'm going to have 5.1, that's a cube, times 5.1 plus the 4. And then my y1 is I just plug in the 5. And I want to get like separate numbers for these. And I actually did. And I know I have a calculator right there. Why don't you show me? Because I get bored. So there you go. And so my formula was supposed to be subtracting those two. So my delta y would then be the 90.751 minus the 84. And I got 6.751. There you go. Okay, cool. So that was part B. That was the easy one. Part A says that we need to take some derivative stuff, okay? So again, let's go y was equal to, let me just remind myself here, x cubed minus 9x plus the 4. And so then they say find dy. All right, so I have the 3 come down. 9 by itself, that thing goes away, slap a dx on it. I mean, that's not too bad. We just did it. Yay, we're done. Whoa, 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 we're so close. They want it at these specific values, yeah? So I have a 5 for x, and then I have a 0.1 for dx. So I'm saying that this one would be a 5. My 5s are getting sloppy. And then my dx was a 0.1. I'm plugging it in. I had an x, I have a dx. I could plug it in. Okay, I'll show you in the calculator. I'll show you. As long as it makes my videos longer, get more views, more monetization on YouTube. No, I'm joking. I don't get any money for this. But like and subscribe. Anyway, so there's your answer for part A. Okay. Again, it wasn't hard. It was just kind of understanding what you're looking at, okay? So take a derivative, make sure you're plugging in for x and even for dx. The next one, here we go. So this one, it was very upsetting to me. I was very frustrated because I sat here looking at this problem for a long time, and I still don't quite understand it, honestly. But I got an answer for you, basically. I haven't even read any of this stuff. Let me just real quick write it all out. Okay. So we have a cube with 8 inches long on each side. Again, remember that a cube has the same amount of sides, top, bottom, length, width, height, all the same, okay? So, and it's covered in this thick covered. I don't know. It's covered in stuff, okay? 0.4 inches of stuff covered. And it says find the volume of the shell. So let's draw a little picture here. We got a cube, okay? And then I'm going to cover this thing with I don't know, like a plastic. Let's cover it with a plastic. Okay, so I'm making it a little bit bigger than the thing on all sides. And essentially, I covered it in plastic, but I only want the volume of that plastic. So this is business stuff, right? So I'm going to say, I want to know how much plastic was used in the enclosure of the cube. The cube itself is done, or maybe it's just empty space because it's just like a box or something. but I need to know what the volume of the enclosure plastic is. And so therefore I can order that much plastic, and I can say, well, that much plastic like times like 1,000 or 10,000 or 1,000,000 of them. And I can give you correct numbers as to how much I need to like order and how much it's going to cost and all that kind of stuff. Okay, so it's actually a really awesome problem. So let's now get through the math of it, and it's a very short amount of math. So volume is equal to x cubed. Yep, there it is. We did it because it's a cube. They're wanting to know how much the volume of the shell is, though. And you're thinking, well, then I've got 8 and the 0.4, mush it together, and boom, we're done. No. Let's keep going. So dv, derivative, it's like v prime kind of. The 3 comes down, x squared dx. Okay, cool. Sounds great. Well, I need to like plug in some of this stuff. And so x is equal to 8, and dx is equal to 0.4. And this is where I went wrong. And this is where I went wrong, basically. And this is kind of weird. It's not 0.4. It's actually supposed to be 0.8. And you might be wondering why. It has nothing to do with this. It's because you went 0.4 on this side and you went 0.4 on this side. So like the extra x, see like how our original cube was right here, and then I went 0.4 here and 0.4 there. So how much extra did we actually have? It's actually 0.8. It's this number right here times 2, because we're going on both sides. If you don't do that, you will get it wrong. That was 30 minutes of my life right there. Anyways, no. I'm not bitter at all. Plug in the numbers that you have. And I got my answer, and that was it. It was very straightforward here. Boom, you're done. So here, I'm going to even verify, okay, because it took me so long. So we got 3, 8 squared, and then times 0.8, and there you go. That's your answer. Watch out for that sort of thing. Those are those little things like that happen. Keep cruising. I got 2 more problems left. So 9, 6, 47. So it has C with a little bar on it. C bar. But this means just average. Just means average, and it means average cost because it's a C, by the way. So average cost is 440 over x plus 6 plus 1/5 x. Okay. And before we even go on with the rest of the problem, I'm going to rewrite this using the exponents like this so that I can take derivatives really easily. See, I just made that into a -1 because I know I'm going to have the derivatives here in a minute. Okay, so it says that we're increasing, or it's increased from 25 to 32, okay? And it says approximate the change using differentials. Okay. As in like the change in cost and stuff like that. So, okay, before we keep going, they're talking x here. And so my delta x, my dx, is going to be 32 minus 25, which is 7. So we got 7. We're going to use 7 here in a minute. I'm going to start here. This will be my x1, I guess. This is x2, but I don't think I'm going to use that. So let's find it. So I need to find my derivative. Oh, there's a bar there. So find my derivative. The -1 comes down, so negative 440x minus 1 from the power. The 6 goes away, and then I have a 1/5 all by itself. Cool. But if you remember how this works, we're not actually finding this. That was like dc bar, and all of this should have a dx, and that's fine. So I'm going to plug in all my numbers. Again, this x, it should be x1 technically, being therefore the 25. And then this is going to be the 7. I already did all this. I already got the answer, but I just want to make sure you're, no, not that. Okay, so -2 power plus the 1/5, all this times 7. Yep, that's what I got. That's what I got. Look at that. Okay. Negative 3.528. Now, they're wanting dollars and cents, and so this is technically $3.53. You don't know how picky this program is. You try to go off by just 1 cent, and the whole thing says, "No, you're wrong, and I'm not going to accept it." And it just doesn't tell you that you're off by 1 cent. So please watch out. Please round correctly. Now, notice that what I did, I had a negative, and then all of a sudden, I just made it into a positive. That was not a mistake. No, it was not. Because instead of an arrow here, okay, instead of an arrow there, they have like a box that you have to click on, and it's decreasing. That's that negative. So we got a negative 3 point whatever, so you're decreasing negative by that amount. There you go. Now we're done. Well, with that one. So 9,651. So last problem. So it says, again, like we've seen a lot of times, approximate the increase of the area, okay, from 10 millimeters to 17 millimeters of a radius of the radius. And I think this is like a pool of water, like you throw a stone in and it goes like wumpa wumpa wumpa, something like that. So and they give you a formula. It's pi r squared for a circle. So they give you the formula. They give you all this stuff for like radius and all that stuff. This is going to be my R1 or just R, and you can see that my delta R, my change in R, my dr is 7, right? I go from this to that, and it's a positive. Sometimes there might be a negative. So dA is going to be pi times 2r, and then r prime, or dr, and I'm just going to plug them all in. So 2 times, and that'll be a 10, and then I say multiply by 7, and I get a number. Let me go ahead and find it for you so I feel legitimate today. Pi times 20 times 7. That's what I got. So 439.82. Good enough. And this is millimeters squared. There you go. And we're done. We're done with that section. I only have one more section left in this chapter. So thank you very much. Have a great day.